question I want to ask is, what color are water molecules? These are red and white, but what color are real water molecules? Actually, water molecules and atoms do not have any color. They don't have any color. This is just the standard representation in chemistry for oxygen in the center and hydrogen on either side. So a water molecule basically looks like a big Mickey Mouse head. So one atom of oxygen and 2 of hydrogen. So Kyle, now go ahead and walk through this room, and you'll notice what happens to the molecules.
They don't
Get out of the way.
They move out of the way, so they behave like a liquid. Now what we've done is we've programmed each molecule, or the molecules, to behave in a certain way. And in this case, they're slightly attracted to each other just like real water molecules. Now you can also use your wand and kind of bat through, and you can splash in the water. So he's actually playing in a pool of water molecules. Pretty nice. Now do this, Kyle. Get down on your knees and stick your head down into the water molecules.
like this.
Yeah. Can you now actually look off to the side a little bit? Do you see spaces between them? Ah, all right. Now, if you would, Kyle, if you would trade your goggles with someone else in the group and give them the wand. Now what we have is we have a thermometer over here on the wall. And now your name with the wand.
John.
John. So if you would, point at the thermometer there on the wall and push the left trigger on the top, the left button on the top, and you'll get a wand. Now change the temperature. What will happen when he changes it to 100 degrees Celsius? What happens to water at 100 degrees C? It boils. All right. So go ahead and take it all the way up, John, first. So he's going to take it up so you can get all the way up to 100 degrees C. then when you get close, let go and then grab it again and then take it all the way up. Try one more time, a little bit further. Oh, there we go, there we go. Okay, now let go. Oh. So now the water molecules are boiling. So now what do you notice about how tightly these water molecules are packed? So they're farther apart. So which is more dense, gas, water, or liquid water? The liquid water. They're more tightly packed together.
Somebody else wants to use it. I guess you can come in if you want.
Well, I'll have another group come in a little bit. All right, so John, now go ahead and take it down to freezing. Okay, now what does, well, go ahead and let go there. That's, yeah, just below freezing. Now what does water do when it freezes? It expands. Why does it expand? Ah, now here we can get into a science lesson, but actually what happens is the molecules start forming a lattice. They form a three-dimensional pattern, and they're actually then, the molecules are then farther apart. So now you can actually walk around through this ice lattice. Now do you see how much space there is between them? So again, why does ice float? It's less dense than the liquid water. All right. So if I could have, does anyone else want to drive for a little bit?
Do you want to try?
Okay, so switch goggles. And then raise the temperature a little bit so we get out of ice.
That's pretty cool. Oh man, man.
And so it's the left button.
Anybody else like a chance with some goggles?